Okay, so for today we are going to look at hierarchical clustering, and this is different from k-means. So remember, k-means was distance-based, so we need to look at another model which is not distance-based. So hierarchical clustering is a tree-based model. Okay, so just like the decision tree and the random forest. So hierarchical clustering is a type of clustering algorithms that groups similar data points into groups or clusters. So it is based on a tree-like structure called the dendrogram. So we are going to visualize the dendrogram and you are going to see how the clusters have been created. So this dendrogram shows the relationship between the hierarchies and the clusters that we have in the data. So there are two ways in which we can create these tree-like structures, and the first way is the agglomerative way, where we start with each individual data point. So we start from the bottom. So we start by looking at each data point that we have. Then we proceed on and merge these smaller data points to be larger and merge them together to form larger groups. Then we have the divisive. So from the divisive way, we start with larger data points and we divide them into small groups. And these small groups will create the clusters that we need. Okay, so the algorithm stops when a stopping criterion is met, so such as a fixed number of clusters or a minimum distance threshold between clusters. So we are going to use this example code that is here because already we've covered what is clustering in the k-means class. So today what we are going to change is just the model. So I'm going to paste the code there from our notebooks. So then I'm going to explain the code so that you can't miss a thing. So here we have from sklearn.cluster import agglomerative clustering.
Dr. Joseph,
Yes.
before we go to the code,
Yes.
uh, would you kindly illustrate using your board
Yes.
just a small difference between the two, because I'm kind of mixed up in a way.
Between the
two,
agglomerative
yes.
and the divisive.
Yes.
Okay, let me find my pen. I don't know where. Okay, yeah. Let me open my board. Then I can show you. Okay, so when coding, you won't get to note a difference between these and these, but I can show you how they work. So here we will have D for divisive. So let me see if I can change the size. So here we will have D for the divisive one, then we will have A for the other one. So here we have our data. So the divisive one starts from the top where we have the larger groups, okay? So that here what we will have is, okay, so what will we have? Let me start with the agglomerative one where we start with the smaller groups. So this one starts from the bottom. So this is the bottom part where, for example, we have data point 1, 2, 3, 4, 5, 6, 7. So here we have these, let's say these groups here, and I've said this thing is tree based. So we are combining them. So this is the agglomerative one. So we are starting from the bottom going upwards, okay? So this is what we are creating so that we can have final thing like that. So that if we wanted 3 groups, this will be our cutoff point, okay? So we have 3 classes. So this is class number 1, this is class number 2, this is class number 3. So this is the break point where we now have 3 classes from 7 classes that we had down here. So this is the agglommerative one. So we are starting from the bottom going upwards. The divisive one is we are starting from the top going downwards, okay? So we can have that. So I'm trying to copy what is on the other side. So we have that. So this is class 7, this is class 6, this is class 5. So you see we are starting from the top going downwards. This is class 4, this is class 3, then this is class 2, this is class 1. Okay, so note that for hierarchical clustering, so we are not using the points like we did in k-means, so where we were circling the points. So here we are using these tree diagrams. So remember when I was teaching you the decision tree class, I had informed you that for a tree, we have these decision nodes, we have the root node and all that. So for us to come over to this side, there must be some considerations made. And for us to come over to this side, there must be some considerations made. And if we want 3 clusters, then our cutoff point will be here for these class. So we have class 1, class 2, class 3. So each line represents a class. So that's class 1, class 2, class 3. And if our cutoff point was somewhere around here, we would have like 1, 2, 3, 4 classes. So around here we have, so here we have 3 classes, around here we have 4 classes. So do you now understand how the two work and how you can differentiate them? So
Yes, yes.
this is the divisive, this is the other one. Yeah, so that's how they look visually. So we are going to create a plot with that. Yeah, so hope you understand this part now. Okay, so let's head over to the coding part. So for the coding part, this is what we have. So we load the model, the agglomerative model, then we load our data set. So after loading the data set, we fit. So x is equals to x dot data, because remember when we were loading the iris dataset using datasets.load iris, we had something like a dictionary, and that dictionary had the data, the target, and everything. So we can run this. And what we can do is, remember, if we open our k-means notebook that we were using yesterday, there was a way in which we extracted our labels. So we said y, let our y be equals to k-means dot labels. So what we will do is I'll change this part here, or we can leave it as it is, copy everything that is in our code notebook. So after fitting the model, what we do next is we plot that dendrogram. So let me copy this, we do the plot, then we will come back to the notes and explain what has been done. Yep. So the first thing we do is we import. So from SciPy, so now we are using a different library called SciPy, and SciPy, we are using it for the plotting. So from scipy.cluster.hierarchy, import linkage, comma, dendrogram. So this will allow you to plot these diagram that I have illustrated here. Then we don't have to import the datasets all over again. Then we need matplotlib. Then we've already fitted the model, so I'll delete that to eliminate the repetition. Then I'll delete that also. Okay, let me see something, if I'm missing something. Yep, so I'm going to delete that also. So here we have to create our Z, and the Z is the linkage matrix. So we get the Z from that. So let's run this, then go through the notes, see what we are doing here. So here you can see this is the dendrogram. So it's almost similar to what we have here. So it's like a tree showing you the different clusters that have been made. Okay, so from the notes, let's see what we have. So we have the linkage parameters. Yeah. So we have this part here, this Z. So in this example, okay, let's see this. The linkage matrix Z can also be passed to the dendrogram function to plot the dendrogram with the linkage matrix Z. So this Z here that we have here creates the linkage matrix. So this is extracted from your data and you can use the dendrogram function. So that's why we have these two libraries imported. So you can use the dendrogram function, plot your tree, which is the
Can you
dendrogram
zoom in a little bit, Joseph?
for the code or
I
for
think I
the
need to confirm on the code.
this part here.
Yes, the
Okay.
linkage X.
Yes.
I don't know what it's even. I don't know. Is it
Yeah.
Z is equals to linkage X,
Yep.
then parameters X word, right?
Yeah.
And what about the word?
What is a what is a hyperparameter? So we haven't discussed that yet. So here you can see like something like word minimizes the variance of the distances of the linkage.
Joseph,
Yes,
sorry. So from that dendrogram,
yes.
okay, from just the coding what we've done, are we able to know if it's either divisive method or the other one?
It depends with your input. Here we imported the agglomerative.
From up there. Okay, okay.
Yep. So if you wanted to do the divisive one, you can also do that. Yep.
So at that moment, at that point, Joseph,
Yes. Yes.
assuming you're going, you are going to use either divisive or agglomerative. Is it agglomerative or something? Yeah. So how do you know the one that fits better that you should be using? How do you know that I should be using the divisive and not
No, you
this?
you won't know. You'll
You
just
won't
have
know.
to, yeah, you'll just have to try maybe both and see, compare maybe the results. Because
Oh,
both work. It all depends with your take. So you can either
oh,
choose,
I got you. I got you. I got you.
because you know we are working with the data that has no labels, and what we are trying to do is create these labels. And the output will be something similar. So it's either you will start the division from the top here, or you will start like combining these small points from down here. So any can do.
All right.
Yep. So these are the labels that have been created by the model. So you can go ahead and visualize them using the same code that we were using yesterday. Yep, and I guess that's all for the hierarchical clustering. So it's somehow complicated, but I guess here on the Notion part, I've created the detailed notebook which you guys can go through and try and understand everything that I've been showing you. So also I think the code example that is here is far more better than what we have in here. Yeah, so any questions so far?
Now, sorry, but I'll ask again on the where we had the word where we're actually trying to feed. We had a few others like I don't know whether you can scroll down.
Single complete
Yes,
average. Yeah.
exactly. Maybe I don't know whether you can differentiate these for us so that we understand. Okay, there could be an explanation there definitely,
Yep.
and what do they mean? Like, why will I not use single Why would I not use word instead of single or complete or even average? Like, what brings the difference in the four?
Okay, so in the four, the difference is brought about what you are trying to change. So you can see, for example, for word, you are minimizing the variance of the distance, says of the linkage. So for you to understand this, you need to go and study the math behind this, right? And that's the reason as to why yesterday I showed you this. So how to use AI to like help you understand some of the things, because I can't like explain this to you in a way that you will be able to understand it theoretically. So I will be required to like demonstrate it mathematically, which will take a lot of time. And here we are here to like see how we can shorten the process for you. So for example, if we look at this, so what I can do is I can paste it here and say what would make me choose one of these and leave the other. And I will be able to get the answer. So for example, here what I'm seeing is in hierarchical clustering, the choice between linkage method often depends on the characteristics of the data and the goal of the analysis. So here's a breakdown. So for example, when you are using Word, the word method is generally used when you want to your clusters to be compact and when variables are continuous. Okay, so maybe I can copy this and I'll paste it to the notes that we have here. So single linkage can be useful when you are dealing with non-elliptical shapes. So it can detect clusters of different shapes effectively. Then complete linkage is good when you want to create more tightly bound, compact clusters and are more concerned about the clusters being separate than about their shape. Then average is a good middle ground linkage method that is often used when you want to compromise between single and complete linkage. It's less affected by outliers compared to single and complete linkage. Yeah, so here you can see the differences that have been brought out by this model. So let me copy this and paste it in the notebook for today's class. Yeah, so you'll have that for your reference. And thank you for asking that question. Yep. Any other thing you need us to clarify? Hello? Can you guys hear me?
Yes,